that does not change. A numerical expression may contain only constants and operations, and an algebraic expression may contain variables, constants, and expressions. To evaluate is to find the value of an expression. Some examples are translating from algebra to words. So if you have this, you can say is x plus 3 the sum of x plus 3 or x increased by 3. For minus 7, you can say is 7 less than if you have 2 times y, it's the product of 2 and 1. And this is the quotient of L. Okay. And from words to algebra. So if for example you have a problem that says if reads 25 pages per hour, and you have to write an expression for the number of pages it reads in each hour, you put 25 times h, which is, and an example of evaluating is that if you have this operation and they give you the value of x, which is 8, and that y equals 5, you just put plus 5, which is 13. That's all.
And today I'm going to explain powers and exponents. A power is an expression written with a base and an exponent. A base is the number that is used as a factor, and the exponent tells how many times the base is used. Here we have this cube is 2 squares long, 2 squares wide, and 2 squares tall. We use the number 2 3 times. So the base is 2 and the exponent is 3. The result of this is 2 times 2 times 2. First, we find the result of the 2 first terms, that is 4, and 4 times 2 is 8. Here, if you want to find the number of dots in the square, you have to multiply these 3 dots and these 3 dots. That are 3 times 3. Here we use the number 3 2 times. So it's 3 to the power of 2. That is equal to 9. Okay, simplifying expressions. Here I have to use the number 2, the term minus 2 3 times. So 2 times 2 is 4, and 4 times 2 is 8. So the result is minus 8. Ciao.
My name is Mariana Gomez, and today I'm going to talk about the square roots and real numbers. Okay, first, the definition. A square root is a number that multiplied by itself gives a product. The square root is composed by the perfect square. The perfect square is a number whose positive square root is a whole number. So I'm going to give you an example. The square roots are represented by this symbol. So the square root of 49 is 7. 7 multiplied by itself is 49, and you represent it like this. And this is the positive square root. The negative square root is like this. So the square root of negative 36 is negative 6, and it's the same. Okay, real numbers. The real numbers are all the numbers that can be represented on the number line. The real numbers are divided by rational numbers and irrational numbers. The rational numbers, the examples are like fractions, decimals, whole numbers, and integers. And irrational numbers are the ones that, for example, don't have a square root, or p, or t. Okay. Okay, there are many real numbers. For example, some ones are natural numbers that are these ones. Whole numbers that are the same, that are the ones that are not decimals. Integers are these ones that are whole numbers with the but are the opposites, so they are negative. Rational numbers that are expressed like this, and terminating decimals that are, for example, these ones, and repeating decimals that are, and the sign is sign on top.
Bye, thank you.
I'm Daniela Luque, and today I'm going to talk about order of operations. So first of all, the definition of order of operations is a numerical or algebraic expression that contains more than one operation symbol. So the order of operation tells you which operation to perform first. You may want to use this color so you won't confuse the answer at the end. So, square. So, to solve it, you solve the one first and you put the answer, and then you keep writing this. Second, you will be solving the multiplication and the division. So first the division, so you copy as it is the result of 24 divided by 3 is 8, so it is in color, and then again as it is. You have to, so it would be minus 16 plus 6. And finally, minus 16 plus 16 is equal to 0. So here we use the order of operations, and the answer wasn't changed of the proper order.
My name is Juliana Hill, and today I'm going to talk about simplifying expressions. We use this to solve operations in an easier way, normally in mental math. We have three properties: the commutative property, the associative property, and the distributive property. The commutative property is that you can add and multiply any number in any order. It doesn't affect the result. An example is 3 times 2 is 6. It's the same as you multiply 2 times 3. It's going to give you 6. The associative property is that you can group any number in addition when you are on multiplying. Here, 4 times 9 times 25. Okay. You can change the order. 9 times 4 times 25. And you can group these two numbers. This is gonna give us 100. And after we have this answer, you multiply it by the number that is left, that is 9. So the result is gonna be 900. And the distributive property is when you are multiplying two big numbers or two numbers that are not really easy to multiply or divide or add, you can divide one of the two numbers. So we have 15 times 100. You can divide this number. So we put 15 times 100 and 15 times 3. So this is gonna give you 1,500. And this is gonna give you 45. And after you have the result of these two operations, you add them and you're gonna have 1,545. Okay, thank you.